Hello everyone and welcome to PaaS Summit session. My name is Novakovic, a program manager lead in Azure Data team. Today, Srijan and myself will talk about SQL application modernization in Microsoft Cloud using the recently enhanced version of Azure SQL Managed Instance. The key takeaway from this session today is that Azure SQL Managed Instance, or SQL MI, is the best option in Azure SQL to migrate and modernize your applications at scale. A couple of information about me. I'm leading the team of program managers who designs and develop Azure SQL MI. I'm with Microsoft for 9 years and have been working on SQL MI from day one. My focus is to coordinate and orchestrate managed instance development across different product areas.
Hello everyone, I'm Srijan Božović, PM in Workos team, focused on SQL MI and networking and security aspects.
I also wanted to mention here our colleague Sasha Popovic, who is also a PM on SQL MI team focused on distributed transaction and migrations. Sasha is not with us in the session today, but he helped us prepare content for this session. Special thanks to Sasha for creating today's demo materials.
Yes, we could not do this without Sasha, definitely.
So let's go through the agenda for today. We will start our session by talking about position of Azure SQL Managed Instance in Azure SQL portfolio with special attention on scenarios when it should be used. In the second section, we will provide details on Platform as a Service capabilities, or PaaS, that are built into Azure SQL MI. This will help you understand what you can expect from PaaS features, how you can interact with them to achieve what you need in your scenarios, and in general, what does shared responsibility model look like in PaaS world. The central piece of our session today deals with SQL MI recent updates and midterm roadmap. During August and September this year, a powerful set of product improvements landed onto Azure SQL MI, while some more exciting long-awaited features are coming soon. SQL MI remains to be a strategic investment in Azure SQL portfolio, aiming to enable application migration with instant modernization in the cloud, and its strong roadmap testifies that. In the section number 4, we decided to put SQL MI networking in the spotlight, and my colleague Srijan will be talking about it in more details. Compute and networking isolation are the key value props of SQL MI, and they often represent reasons why SQL MI is being chosen by customers in regulatory industries. Yet, traditional SQL users might find themselves unfamiliar with SQL MI networking configuration. We wanted to shed some light here and explain what to use when and how to create highly performant and secure SQL environments with SQL MI networking. Our demo for today illustrates practical use of some recently announced capabilities to build modern, scalable, performant, and globally distributed applications. You will see how you can use distributed transactions and global VNet peering to make this task easy and fun. And after demo, we'll be proceed with a Q&A session for the remaining time. Let me start by giving a high-level positioning of the service that we are talking about today within Azure SQL portfolio of services. Azure SQL is a highly secure and intelligent modern SQL portfolio powered by the industry-leading SQL Server engine that has evolved and perfected over 25 years now. And the portfolio is currently comprised of 3 services within 2 service control models. SQL Server on Azure Virtual Machines, our infrastructure as a service offering, which helps you avoid the expense and complexity of buying and managing your own physical servers. And Azure SQL Managed Instance and Azure SQL Database are platform as a service offerings, which also include infrastructure, but also the middleware, development tools, database management systems, and more. With Azure SQL, you can rehost and lift and shift your SQL workloads, but you can also modernize existing application or build new cloud-native application and manage them through a consistent and unified experience. In all overviews of Azure SQL, you will see managed instance position in the middle between SQL on VMs and SQL DB. On one side, with its high compatibility with SQL Server engine, it's very similar to SQL on VM. On the other side, it shares the platform with SQL Database, hence they share majority of platform as a service capabilities. That's why managed instance is best positioned for modernization of existing solution. If you are to attach some keywords to these services, for SQL MI, it would be compatibility and modernization. For VM, full control and lift and shift. migration, and for SQL database, innovation and flexibility. Now, let's now transpose these metrics and start from the requirements, capabilities, and level of control, which then lead to a service of choice. It is important to notice that there are only two aspects to kept in mind when making decision on the destination in Azure SQL. First one is level of control that you need or want to have over the database layer. To simplify this, answer this question: who should be managing your databases, your DBA team or Microsoft? And the second aspect are the SQL capabilities that your application and workloads need. So in terms of capabilities, there is a limited set of requirements that are tightly coupled with having a full control. If you need features like full SQL Server features, and then if you need to install the third-party modules side by side with SQL, if you need direct access to operating system or disk layer, then SQL on VM is your choice. But you'll still have benefit of automatic updates and security patches. So definitely, if you are aiming for the full control, the VM is your choice. Control is a great thing, but it comes with a lot of responsibility and manageability burden. And many of our customers are not willing to invest time and energy in database management. For these customers, our platform as a service offerings represent optimal choice. So how you should be thinking about SQL managed instance versus SQL database dilemma? It really boils down to the programming model of your application. Do you need instance level model and rich surface area, including features like common language runtime, SQL agent, transactional replication, service brokers, and many more? If answer is yes, then you should be going with SQL managed instance. But if your application is okay with a little bit simplified database scope model, then SQL database is a perfect choice for you, and you can start optimizing and leveraging platform as a service capabilities from the day one. This slide quickly summarizes the key benefits of SQL MI, and we call it the 4 pillars of SQL MI. And the first 2 pillars we already talked about, the no migration friction and productivity with paths. They provide a nice balance between SQL Server compatibility and automatically managed service benefits in the cloud. There is also another aspect that we want to bring to your attention. It's ultimate security that you're going to get with SQL MI. The level of isolation is best possible with SQL MI thanks to its native VNet integration and private endpoint enablement. To put it very simply, SQL MI is a fully managed service deployed in your virtual network and on the compute virtual cluster that is dedicated to your tenant and which is not shared with anybody else. So the 4th pillar is a non-technical aspect but is also an important one. SQL managed instance supports different ways for you to save money while modernizing your applications. So you can bring your own license and that's supported through the Azure Hybrid Benefit model or AHAB. Secondly, there's no licensing charge for dev test environments. You get that automatically by deploying SQL MI on dev test subscription in Azure. And the third aspect is a reserved instance benefit that can be either 1 year or 3 year. Combined with Azure Hybrid Benefit, reserved instance provide up to 80% of discount compared to license included model. Let's start with our next topic, platform as a service on your own terms. And it will be talking about how productivity of your database administrators and developers can be increased based on database management capabilities that you get out of the box with Azure SQL MI. We'll go through several standard set of database management tasks and see which tasks can be offloaded to SQL MI service and how much of the control stays in your team's hands. Let's start with the service deployment aspect. We will use the classification of activities provided by the system and activities staying in your team's responsibility. So when provisioning SQL MI, you get to choose hardware generation, service tier, compute and storage size, but service is doing all heavy lifting regarding the hardware allocation, integration with your virtual network, including setting network policies for interrupted managing traffic and more secure data traffic protection. And finally, deployment of the latest stable SQL bits. So what's in your control besides the service tier and hardware selection? You can also issue deployment from various tools, Azure Portal, using the ARM templates, PowerShell, Azure CLI, and you can schedule and monitor deployment process programmatically and build more complex deployment workflows that include other Azure services. With SQL MI, you are switching to the latest and greatest or evergreen version of SQL Server. And there is a good news. This is the last SQL migration that you ever perform. SQL team will continue to maintain your binaries on a regular basis, making sure that full stack, including physical and virtual machines and SQL instances, is secure, stable, and performant. And not only that you will run the most stable platform, but you'll be able to first get new cutting-edge features that SQL team is regularly developing and releasing in the service. SQL team is following very strict and rigid so-called safe deployment process, which main goal is no regression for any application running on our platform. The years of improvements and millions of databases running on Azure SQL 24/7 made this process very, very solid. Hence, promise of this latest SQL migration is strong and very real. Now, with delegating us to patch the platform for you, you can focus your energy on making your database schema and application as much optimal as possible. On this slide, we are talking about networking, security, and connectivity, and we will be talking about this aspect in the next section, but this is just a teaser. Platform as a service stack does not apply only to the core database features. With SQL Managed Instance, your subnet where managed instance is deployed is also being managed by our service in order to provide best possible level of protection. Let's talk about the certificate management. If you were in charge of maintaining large and complex environment on premises, you probably know how much of effort is needed to be invested into timely certificate management and maintenance. In Azure, that's something you get out of the box. Any communication from or to your service is managed and maintained by SQL MI platform, be it for the communication stack or automatic database at rest protection, secure failover group communication, etc. So that doesn't mean that you are fully out of control. For example, some of our customers need to control database encryption keys, and that model, bring your own key, is also available for TD thanks to the AKV integration.
And let me add here, TLS selection is another option when you are in control. As a platform, we would like to have you choose the most secure option, that is, as of this recording, TLS 1.2. But for various reasons, your platform might not be ready for this option. For that reason, we provided escape hatch as a selector to choose some downgraded TLS option.
Thank you, Susan. This is very, very informative. And our next example of shared responsibility model is Highvaluability and disaster recovery. Some would say HA&D are the most critical aspects of any PaaS service. And we as a team put a huge amount of work and energy to make this as smooth as possible and as stable as possible. If you ever tried to configure a SQL cluster on premises for high availability using either Windows Failover cluster technology or always on, you have an idea how complex that could be. Now you get high availability with one click during managed instance provisioning. And not only that, but it's also 24/7 monitored by our PaaS service and guaranteed by financially backed SLA, which is actually unique in the industry. Similar stands for disaster recovery. With just a few clicks, you get your databases replicated into another region with the ability to rely on automatic or manual failover procedures in case of primary region is affected or is down. Yet you have flexibility to choose cross-region connectivity options to properly size your geosecondaries and control failover, which happens fully transparently for your application and without need to change even the application connection string. Next example of PaaS helping you is related to the database backup. This is another critical option for PaaS that guarantees business continuity. So backups are automatically configured by default from the moment you start with SQL MI, and thanks to them you can restore your databases to any point in time within the retention period. And that applies not only to your active databases, but also to your deleted databases. You can also restore your automatic backups to the same, but also to a different region, achieving the disaster recovery solution with the downtime. Automatic backups are implemented in a way that minimally impact your main application performance, because we apply internally resource capping. With additional knobs that we provided for you, you have the influence how system works, how long the backups are being kept, and you can also control when to issue the point-in-time restore and stuff like that. And finally, this slide summarizes how to achieve a very common scenario in authentication, which is single sign-on to SQL MI. Basically, it's a question how you can enable your on-premise customers or users to connect directly and authenticate against SQL MI using their on-premise credentials. With Azure Active Directory, while Azure Active Directory provides the support for AD integrated auth, and SQL MI supports mechanism to map existing Windows DB users to AD, there are some steps and some controls that are in your hands. For instance, the account sync between on-premise and AD is something that you configure and control. Azure Active Directory federated services that actually are helping with the integrated authentication flow. Also, updating client drivers is something that you have a control. So maybe, Srđan, you would like to add some additional aspects here.
Yes, I would like to add that Azure AD authentication journey does not end up with AD integrated authentication. What we plan to support going on is native Kerberos protocol for Azure AD user authentication. The goal of this project is to enable legacy clients to benefit from Azure AD authentication.
Thank you, Srđan. This is very good to know. Looking forward to having the Kerberos out in our PaaS services. In this section, we will bring to your attention recent product updates, and we will discuss several interesting capabilities planned to land to SQL MI very soon. And this section will hopefully give you some ideas how to leverage these new capabilities and features to modernize your application while migrating to SQL MI. On the following slides, in this section, we will use the following annotation. So features are divided in up to 3 categories. Available section lists out release features. You will find features that we made available in last, let's say, 12 months, but special attention is on recently added features, last 3 months, which are marked with green color. The second category are the features that we are announcing at PaaS Summit conference, and the third section are the coming soon features that are expected to land to our product in next 2 to 3 months. Slides are separated by key areas, and we start with SQL Server compatibility, which is very important for seamless application migration, as it guarantees no code change for you. And for this slide, there are a couple of important callouts. Among recently added features, there are Ignite announcements. A couple of things that we announced end of September. First is support for machine learning services and distributed transactions that reach public preview. And the second one is ability to host SSRS catalog databases, any version of SSRS, which reached the general availability. Today we are announcing the log replay API for SQL MI that allows customers to send full, differential, and log backups programmatically and perform minimal downtime migration to SQL MI. Log replay service is the API used by data migration service, which is now open for direct customer usage in form of a PowerShell and Azure command line interface. And in the coming soon section, there is support to use service broker between the instances. It completes service broker feature that has been available for databases belonging to one instance only since the MI reached the GA. Now, you can combine databases sitting on different instances and send messages across them. A few information about distributed transactions. So we expect that this feature will help not only with application migration, but it also unlocks some development scenarios. So if you want to build or re-architecture application SQL and utilize multiple databases, horizontally or vertically partitioned, distributed transaction will be a great capability for you. We do start preview with SQL Managed Instance as the only participant in these transactions, and with .NET and T-SQL as the programmatic ways to run these transactions. Please stay tuned for updates in this area, and let's see these features in action in our demo later on. The next area is covering business continuity and disaster recovery, and here there are two features that I wanted to specifically call out. Accelerated database recovery. With ADR, long-running transactions do not impact the overall recovery time, enabling fast and consistent database recovery irrespective of the number of active transactions in the system or their sizes. With accelerated database recovery, transaction rollback is instantaneous, irrespective of the time the transaction has been active or the number of updates that it has performed. And finally, with ADR, the transaction log is aggressively truncated, even in the presence of active long-running transactions, which prevents it from growing out of control. So all great capabilities of ADR. The second feature that I want to emphasize here is the global VNet peering. It has been recently added, and it enables you to seamlessly connect networks, virtual networks in different Azure regions and deliver optimal performance in any cross-region or cross-instance scenario. Main use case will be to improve the synchronization in GeoDR scenarios, especially in the seeding phase. But it's welcome in other scenarios utilizing, for instance, distributed transactions or transactional replication. Now moving to the security and compliance area. Early this year we made a switch to accept only traffic with the version 1.2 of Transport Layer Security or TLS protocol for the increased security, and to block any potential future protocol downgrade attacks and other vulnerabilities. This is also true for the outbound connection from SQL Managed Instance to, say, your on-premise SQL. If you plan to implement such a solution and your on-premise version of SQL Server is older than 2016, make sure that you have proper updates applied on the SQL Server side for communication using TLS 1.2 to enable these scenarios. We also introduced and early this summer enforced usage of service-aided subnet configuration that we mentioned before as the way for the platform to keep your VNet, NSGs, and UDRs up to date and in compliance with minimal requirements. The rules added by the system are transparent, visible, and it can be easily recognized based on the prefix in their names. Among the recently added is the backup data residency, and it's very important features. By choosing a locally replicated storage or zoned replicated storage, which is suggested, not only that you will optimize your backup costs using the less expensive storage option, but you also will get in compliance with the local regulation that may apply for your country. In performance scale and cost section, a couple of interesting improvements have happened recently. I'll cover them on separate next slides. Let's start with the SQL MI performance. A set of major performance improvements for Azure SQL Managed Instance have landed recently, which enable you to migrate your more performance-hungry workloads to Azure SQL MI. These improvements include more than double transactional write throughput for general purpose and business critical instances, and superior data and log IOPS for business critical instances. Increased performance, predictability, and stability for general purpose service tier through better integration and enhanced MD performance are also included. These performance improvements are automatically enabled for all existing and future managed instances at no extra charge. We also introduced few features that will help you with controlling backup costs and making use of backup storage more efficient. First off, there are new options for you to control the period of retention. It can be reduced down to 1 day for active and down to 0 days for deleted databases. Secondly, we improve compression to all databases and their backups. And finally, locally replicated storage option and zone replicated storage option, in addition to geo-replicated backup storage that was the default. These options can drive cost of keeping backups much significantly down. A couple of very interesting capabilities are also happened in the monitoring and manageability area, and I'm going to cover some of them on separate slides. In this area, I just wanted to bring to your attention that you can expect resource health for SQL MI to land in the upcoming period with critical information regarding instance health and availability provided for you. So let's talk about AAD directory readers role assignment, which is currently in preview. Users can now assign groups to directory readers role in Azure Active Directory, and this change will promote ease of use when setting up AAD admin for Azure SQL database and Azure SQL managed instance. Effectively, AAD authentication configuration for individual managed instance does not require global admin or privileged role admin actions anymore. With this change, setting AAD authentication will be much simpler and streamlined in large organizations. At the high level, improved process will look like this. First, setting the global with the global admin or privileged role admin, you need to create a new AAD group where managed identities of SQL managed instance will reside and assign directory readers role to this group. This action needs to be performed once per Azure AD tenant. And then assign group owners to the group, any Azure ID users without any specific role. And then group owners then can add managed identity to of an instance to that group and effectively which set the AD admin or at the individual instance level. Finally, in the monitoring area, the SQL management pack was based on SQL Server management pack, and it's the closest thing to SQL Server monitoring we have with SQL managed instance. If you have a hybrid data environment and SCOM is your preferred monitoring solution, you can now use it to monitor your Azure SQL managed instances in addition to on-premise SQL Server, SQL VMs, and Azure SQL Database. We released public and private preview versions earlier, but this management pack is a complete overhaul to reflect the changes in both SQL management pack family and managed instances. Let's now talk about the new scenarios unlocked in high availability area. In August 2020, we have released a new feature which is called user-initiated manual failover, allowing to manually trigger a failover on SQL managed instance using PowerShell or CLI, or through invoking an API call. Manually initiated failover on managed instance will be an equivalent of the automatic failover for high availability and software patches initiated automatically by the service. Manually invoking a failover on MI will help you test end-to-end application for full resiliency on automatic failovers in case of a planned or unplanned event before deploying to production. In addition to testing how failover impacts existing database sessions, it can also help you verify changes the end-to-end performance due to changes in the networking latency. In some cases, if performance issues are encountered on SQL MI, manually invoking a failover to a new node can help mitigate the performance issue. Finally, in service deployment, there have been some notable improvements, especially when it comes to better operation reliability, speed, and increased transparency. I'll cover them in more details on the next slide. Before leaving this slide, I wanted to share that ability to control maintenance window and get notification is getting closer to public preview. So please stay tuned when it comes to the announcement in this area. Azure SQL Managed Instance provide management operations that you can use to automatically deploy new managed instances, update instance properties, and delete instances when no longer needed. Most of the management operations in SQL Managed Instance are long-running, but until now it was not possible for customers to get the detailed information about the operation status and progress in an easy and a transparent way. Through the introduction of new CRUD API, the SQL MI instance resource is now visible from when the create operation is submitted. In addition to the new operations API, Operation API has the ability to monitor management operations, see operation stats, and take the, dependent action based on the operation progress. Besides transparency, we wanted to share that overall reliability was significantly improved in case of 99% of operations are in the expected time windows. Also, some internal operations such as virtual cluster resize was significantly improved and accelerated. As a result, operations like subsequent instance creation or general purpose vCore scale up or scale down was accelerated around 35%. Now onto the section that we named SQL MI Networking One-on-One. We previously mentioned that especially SQL users find themselves unfamiliar with the networking configuration. So my colleague Srdjan will actually talk about the common scenarios and typical networking configuration and help you understand when to use what in case of a different networking scenario. So Srdjan, feel free to help us understand.
Yes, before diving deeper into more details, I would like to quickly show the variety of connectivity options Managed Instance provides. Managed Instance is secured by default, so it resides inside a customer VNet. This makes a Managed Instance easily reachable from Azure VMs or other injected services like app service environments or Azure Kubernetes service. Establishing a connection from on-premise is easy as well, and both VPN and ExpressRoute work.
That's great, but what about the multi-tenant cloud services like web apps? Is it possible to connect them as well?
Yeah, thanks for asking that. Basically, web apps are a great example of how multi-tenant service could integrate with a VNet. SQL MI fully supports this kind of integration. But also there are other services like Power BI that are not yet VNet integrated. SQL MI has an option to enable connectivity over public endpoint to enable access from such services.
Thanks, Srdjan. So one thing that I would like to note is that your diagram now shows VNet peering as option to connect resources from different VNet. Is this functionality limited to peering in the same region, or global peering works as well?
Yeah, later this year, actually end of September, we enabled global VNet peering for all new clusters. And with global VNet peering set, customers can securely connect to their managed instances in a different Azure region without bandwidth restrictions, with low latency and high throughput. For this reason, global VNet peering perfectly fits into GeoDR scenario that we mentioned previously, but it's not in any way limited to it. Global VNet peering would work for any SQL MI connectivity scenario.
Oh, indeed. One such scenario is enrolling managed instances placed in two different regions into distributed transactions, and we will actually plan to demo that later in our session.
Now let's go a bit deeper into managed instance architecture and see how we provide 4/9 availability. First thing that people would need to know that managed instance is not a single VM. It is hosted on a cluster of VMs managed by Service Fabric. Depending on the specialization inside the cluster, VM could belong to one of two roles, database or a gateway. VMs that belong to database role host SQL Engine. If one of them fails, SQL Engine is brought up on another VM. On the other hand, VMs in the gateway role are here to accept incoming connections and based on Service Fabric metadata forwarded to the VM that currently hosts the engine. For high availability, gateway VMs are stateless and placed behind the load balancer. Server name of each managed instance placed in a cluster basically resolves to that load balancer IP address.
Oh, I see. So I would say that it's not just that gateway plays crucial role in SQL managed instance high availability, but also ensures that after failover, client application gets connectivity back very quickly.
Yeah, Borko, that's 100% true. But thing to have in mind is that this design also has some constraints. Most notable one from the network security perspective is that all managed instances in a cluster share the same IP address. Basically, that's the IP address of the load balancer that runs them. That means that you will not be able to set different firewall or energy rules per single managed instance. From the manageability perspective, we could not guarantee that this IP address won't change, as due to the maintenance, we might need to move instance to another cluster. We are thinking of different ways to address this issue. One of the approaches that we are currently thinking of is setting private link for a managed instance.
I see.
Now, with a better understanding of virtual cluster architecture, let's now revisit connection types. Initially, what we now call proxy was the only option. All the data traffic was flowing through the gateway, and you could see this on the left side of the screen. It turned out that this is not optimal solution for scenarios that require low latency or high load, like, for example, bulk insert. So to address this concern, we provided this redirection connection type. With the redirection, as you can see on the right side of the screen, only the first session is established through the gateway. Then all subsequent communication goes between client and SQL engine directly.
Okay, so Susan, let me understand one thing. Redirection is obviously more performant than proxy. So I believe that many of the attendees would wonder why it's not the default selection.
Yeah, the thing is that redirection requires additional range of ports to be open on firewalls, and that's not commonly the case inside the enterprises. So in order to make this initial setup easy for our customers, we'll add proxy as a default option. And then obviously they could switch to redirect.
So you mentioned firewalls and network appliances. I believe that for our audience that is SQL focused, configuring Azure networking stack was one of the biggest challenges. Is that correct?
Yes, that's correct. And making network configuration simpler was really kind of one of the most heard feedbacks that we received. So to address that, we introduced service-aided subnet configuration, and the only thing customer needs to set with this feature is to basically delegate subnet to managed instance. Once the subnet is delegated to managed instance, we as a service could take it for there and set all the required configuration for our customers.
But is that the only benefit that comes out of the service-aided subnet configuration? Are there other benefits that you can maybe enumerate or list out?
Yes, that's correct. That's really not the only thing. That was key motivation, but also based once we kind of supported subnet delegation, all the other benefits came out of it. For example, from the security perspective, subnet delegation enables separation of duties, because if network admin already delegated subnet to MI, then SQL admin does not need additional permissions to deploy managed instance there.
Oh, I bet that our enterprise customers IT department will love that.
You bet. And in addition to that, with more control over managed instance subnet, we were able to unlock more network functionalities, like service endpoints, for example.
Okay, when you say service endpoints, the first thing that comes to my mind is the virtual network firewall. What are the options for locking down storage accounts?
Basically, all options are available here. As you already mentioned, a customer could utilize service endpoints to lock down the storage account with VNet firewall rules. The other options that gains popularity these days is private link.
Yes, network admin seems pretty excited about private link these days, but what it is about?
Private link is a way for customer to create a private endpoint, basically a virtual NIC associated with that storage account. So when traffic reaches this virtual NIC, it is tunneled through the Azure backbone to the storage account and back. One thing that people should take care of in this scenario is network security group. Because with private link, the traffic to storage account flows through the customer network. So you need to ensure that all these network security groups and eventually firewall rules are open to this storage account. And luckily, a storage account uses standard HTTPS protocol over port 443.
Okay, speaking about private link, are there any plans to enable it for SQL MI? Having in mind that SQL MI is already VNet injected and using private endpoint, does it make sense to provide private link option as well?
Yes, we will provide private link in the future. There is some exploration work around it. So there are a couple of benefits. It's not completely the same thing. In addition to private link connectivity, private link also enables connection from private connectivity from completely different tenant. It also enables to connect from different VNets that share address prefixes. So this is kind of very popular ask, and we are really looking into future of implementing that.
So are you saying it's not a replacement for the VNet injection of SQL MI, but it's in a way it augments the basic scenario?
Yes, it's really more than private VNet connectivity.
Thank you, that helps. Let's spend a few more minutes on storage accounts and data exfiltration scenarios. Some of our customers pointed out that with the current networking configuration, you could do backup to any storage account in Azure. Should they be concerned?
Well, there is no real reason for a concern, as there are really many controls in place there. But of course, defense in depth principle that leads managed instance development requires to think about the networking layer as well. And having that in mind, we started working on enabling service endpoint policies for storage. What you could do with this feature is basically set a policy on a network, and with policy set, only traffic to storage accounts that are included in the policy are allowed. The work on our side to enable this to ensure that once policy is set on the subnet delegated to SQL MI, all the storage accounts that SQL MI internally uses, for example, for remote storage or for the backups, are included.
Oh, this would definitely close these data exfiltration paths, and I also like the policy approach to managing security. Thanks, Rajan. This was very, very informative.
Thank you.
Okay, let's switch now to our demo that showcases the use of recently added distributed transactions. While this feature can certainly help with migration of application leveraging it on premises, it has value in new scenarios as well. Quite often, applications need to split data into multiple databases, either to overcome instance sizing limitation or to partition data across geographies for better access performance. And we refer to these databases as sharded. There are several scenarios where distributed transaction across databases and instances can play an important role. The recent availability of distributed transaction made development of these applications possible. We'll use this diagram to illustrate the architecture of our globally distributed application. Say that our demo application is designed to track customer orders and product delivery across multiple geographies. In order to provide best possible performance on the database side, customers or tenants are sharded across two regions. In this example, so that majority of traffic between the application and the database is local. An application is designed with shared database pattern, and there is an admin application as well that takes care of properly assigning new tenants to the regional local databases. In scenario like this one, not all database access patterns can be local within a region. The simplified model of this application has three main entities: products, customer, and orders. While customers and orders are typically local in this design, products are shared and represent master data that needs to be updated consistently across all databases. That's exactly the first scenario that we show in this demo. Second scenario is a bit advanced. Let's imagine that one of the application tenants changes its geolocation. We need a transactionally consistent way not only to move this tenant from one sharded database to another, but also to update shard map so that move customers is now handled optimally in the new region by the another application copy. So there are valid scenarios that require an efficient cross-region communication and data exchange. To simplify networking setup and deliver optimal performance, we will configure our instances to use global VNet peering. And this and more will be showcased in our demo.
The first thing we need to do is set up VNet peering between West Europe and North Europe regions. We will go to the West Europe VNet, then go to the peering section and add a new peering. This will enable us to set peering in both directions, but we need to type the name of the peering a bit differently because we are peering West Europe to North Europe. We will set this name, and we need a name for another direction as well. Okay, let's set up name to indicate that we are peering the other directions from North Europe to West Europe. Then select the North Europe virtual network and click Add. Now the deployment is triggered, and the peering in both directions we will set up so that we could connect these two instances. Peering is finally finished.
Now let's showcase the first distributed transaction scenario. So we here have two instances of our client application, each handling data in its own local region. So the first copy of this application is handling data in the West Europe, while the second one is handling data in the North Europe. And as you can see, data is sharded so that customers in first range from 101 to 104 are located in the West Europe, whereas customers from 201 to 204 are located in the North Europe. And of course, both applications share the common master data or information about the products. So I connected here from the administrative script that is illustrating how we can run the distributed transactions between the two instances and insert a new product into this database. So in order to insert the product, we will actually execute the store procedure sp create new product, and we will now illustrate how that procedure looks and which of the new transact SQL constructs it's using. So we will open this store procedure before executing in a new window to show the code. So basically we are using the link server connectivity between two instances, West and North Europe, and we are using the newly supported construct begin distributed transaction to insert the new product information in two databases in a transactionally consistent way. So when we execute this statement, the new product called my new product should appear in both of the application instances here. So okay, now we executed this script, and as you can see, it inserted the new product 7706 ID, and it now appears in the both tables. And if we go and refresh our application, we will see the my new product appearing in a transactionally consistent way in both applications. So that was the first distributed transaction scenario, inserting the new master data that is available across multiple regions. Now onto our second scenario. Our second scenario is actually ability to move tenants in a transactionally consistent way across the regions. So imagine that our customers with ID 102 needs to change its region. It's currently mapped in West Europe, and we want to transfer the customer along with with customer data to the North Europe region. But at the same time, we want to update the shard map information so that the application in North Europe region is actually handling the data of the customer that is being moved. And again, we have a mechanism to do that in a transactionally consistent way. Before I run the script, I'll actually show how that's possible. Our admin application actually is using the method moveTenant and new transaction scope capability that now works for SQL MI. So both databases, shard map database and the user databases, are hosted on the same instance. And there is also a regional copy of the application database that is available in another region. So if we open this in Management Studio, we can see that basically databases S001 alpha and beta represent the databases for the application, and the shard map catalog that is available in West Europe contains the map between the tenants and the shards. So basically we will run the transaction from the application.NET code that will transactionally move the data and update the data across these three databases, and as a result our tenant will appear in another region. So just a quick look at the application code, transaction scope class that is actually getting the shard, moving the offline mode, moves the tenant data, delete the old mapping, create a new mapping in a new region, and promotes the new mapping to be active. So all of that is being done as a single transaction. And here how it looks when we execute from this main application. So let me initiate this operation. As a result of this operation, we should see that tenant 102 was moved from the West Europe to the North Europe along with its orders. So basically, the entire operation has been completed as a single transaction. So it's a power of distributed transaction in SQL MI.
This is really great because it really helps all the folks who are working on these new modern global distributed applications to use all the benefits of SQL to achieve a transactionally consistent state of their databases globally.
Exactly, Srijan. Exactly. And there are other scenarios that are also possible. You can imagine correcting the data that landed in one shard and has to belong to another shard. So there are multiple scenarios in which transactions across multiple databases, even if they are globally replicated, are possible with this capability. And thanks to the global VNet peering, all of these scenarios will be performing in a scalable and very performant way.
Yeah, people would love this.
I hope you enjoyed today's presentation, and I'd like you to take away a couple of key points. First off, SQL MI is the strategic investment in Azure data that is being rapidly improved based on your feedback. You've seen lots of things coming in last several months, and we gave you a sneak peek at the coming soon roadmap. You can rest assured that SQL MI innovations are not finished with this. Stay tuned in calendar year 21 for more exciting capabilities.
SQL MI is Azure SQL deployment option that provides a kind of best balance between full SQL Server surface area and a modern database as a service that take over from you tedious DB management tasks and help you focus on your business and your application. As such, it is well suited to give you instant modernization while you migrate your databases to Azure.
And finally, I'd like to close with this simple statement. Migrate your SQL Server to Azure today. Azure is the best place to run SQL Server, while SQL MI is the best option to start their journey, as it's built to make your migration seamless and to give you benefits of a fully managed service from day one. So with that, we are done for today. Please explore everything PaaS has to offer to you and use all free resources available online. Secondly, do not do not miss to submit your evaluation for this session. We really appreciate your feedback and we would love to hear it. And with that, we are switching over to the questions and answers for this session. My colleague Srdjan and myself will be there to answer any question that you might have. Thank you very much again.
Thank you, guys.